Hello students, we'll solve problem from general force system. First you have to concentrate what? Any inclined force is there and its inclination is known or not. Yes, there is one inclined force 200 Newton and its slope is given. And this one is, say, if I'll represent this one angle and this angle is any angle alpha. Is it possible to find out inclination of this force? So tan of this angle if we'll take tan of this angle alpha equal to what? Opposite upon adjacent. Opposite how much? Opposite to angle is what? 3. Adjacent is what? 4. Tan inverse of 3 by 4 will get angle alpha. Alpha angle comes out to be 36.869 means we'll take 87. This is inclination. Now you can resolve this force along x and y axis. If we'll resolve, we'll get two components. Two components means horizontal component. If we'll represent, this will be what? Rightward. See direction of force. And from this one again direction of this component will get what? Downward. Magnitude of vertical component comes out to be 200 sine, right? Because inclination is given with horizontal component cos, vertical is sine. Horizontal component 200 cos of alpha. That means now finding Rx, Ry, R theta, I think there is no issue, right? Chalo, start. Now what we'll do? First we'll find out component of resultant along x-axis. So Rx, if we'll write here, our equation is what? Rx equal to summation of Fx. Our assumption is what? Rightward force is positive. Summation of Fx, assuming rightward force is positive. Now concentrate on all forces which are in horizontal direction. The first component of 200 rightward plus 200 cos alpha is what? 36.87, number 1. Next, which force is in horizontal direction? So there is only one force here, right? Topmost location on right side, 100 Newton rightward plus this is 100. Any other force in horizontal direction? No. That means Rx comes out to be definitely positive, and this one if you calculate, what answer we'll get here is Rx is what? This will comes out to be 260 Newton. This one is what? 260 Newton. Answer positive means we'll write rightward. Next step is what? We'll find out Ry. That is summation of Fy assuming upward force is positive. Now in vertically upward direction, what forces will get? One is 40 Newton upward, okay, plus 40. Next, that 80 Newton downward, yes, minus 80. Next is what? 200 sine alpha downward, right? Minus 200 sine alpha is what? 36.87. So this one Ry comes out to be how much? Minus 160 Newton. Answer negative means Ry equal to 160 Newton. This is in downward direction. Now to find out this magnitude and direction of resultant, I'll represent direction of this component. So this will be what? Rx rightward as it is represented here. Ry you are getting in downward direction. So this is what? Ry. That means our resultant force is in this fourth quadrant. This is R. Angle is what? Theta. You know magnitude of resultant if you want to find out, we'll use Pythagoras theorem, square root of Rx square plus Ry square. That means here if we'll substitute Rx as 260, Ry 160, we'll get magnitude of resultant and is equal to 305.28 Newton. Inclination if we'll find out, it is a tan inverse of Ry upon Rx, and we'll substitute with positive sign both. Ry upon Rx. Ry is what? 160. Rx is what? 260. Right? Negative sign already you have considered for Ry negative. Therefore, we are represented downward. That's why you are getting R in fourth quadrant. That means while substituting in this formula theta equal to tan inverse of Ry upon Rx, we'll substitute with positive sign. This angle comes out to be 31.6 degrees. That means finding Rx, Ry, R theta is simple, right? So Rx, Ry, R theta is ready. Now you have to find out this resultant. See, determine the resultant force and locate it with respect to point A. That means resultant position of resultant with respect to A you have to find out. That means this point is important. So what we'll do, we'll take moment of all forces about point A to find out point of application of resultant. So sum of moment of all forces about point A, taking anti-clockwise movement positive. So one by one, if we try moment of all forces, first one say moment of this 40 if we take. So 40 upward, imagine from A to this location corner of plate as a rod, apply force in upward direction, what will get anti-clockwise movement due to 40 plus 40 into, now what distance, force vertical, line of action vertical, perpendicular distance becomes horizontal, that means this is what, 200 mm, first force, right, 40 Newton. Now 100 Newton what force is acting in rightward direction. If you imagine there is what, a bar like this, right? From this A to this point. Now what will get, this bar will rotate about point A in what direction due to 100? Clockwise direction. That means minus 100. Which distance? Force horizontal. The perpendicular distance is what? This will be vertical distance. That means this one is what? 200. The moment of 80 Newton if we take, right, moment of 80, the about point A moment of 80 becomes anti-clockwise plus 80, what distance, force vertical, perpendicular distance, horizontal distance is what, 300. Now there is 200 sine alpha one component, 200 cos alpha one more component. Due to 200 cos alpha, if you check what is the movement, you'll get some movement due to both. Movement of 200 cos alpha is not zero because you are taking movement where about point A. Movement of vertical component about A is in which direction? Anti-clockwise plus 200 sine alpha into, what is the distance, line of action of 200 sine alpha vertical, distance becomes horizontal distance up to A is how much, 600. Then next moment of horizontal component of 200 cos alpha, right, about A, again anti-clockwise plus 200 cos alpha. What is the distance? Perpendicular distance. Perpendicular distance between line of action of force and point A means moment center is what? 200. So this one is moment of all forces about this point. I mean next point important is what? Our movement, right? The movement if we take, so this movement unit of movement is Newton meter, and here all distances what you have substituted they are in millimeter. Therefore up to this one what movement you are getting is in Newton mm. So one possibility, you may convert distances in meter and substitute, or you can convert this kilonewton meter in Newton mm. That means this will be what, 40 into, a meter if you convert, this will be what, into 1000 Newton mm. That means if you find out, this will be what, if you write here again movement is in which direction, clockwise, minus 40 into 1000 means 40,000. Unit what will get here, all are in Newton mm. If you find out this sum of moment about this point A, this one comes out to be 76000 Newton mm. If you want to convert in Newton meter divided by 1000, so what will get, 76 Newton meter. What answer you are getting is positive, that means this moment is what, anti-clockwise. Now this resultant R what we are getting will represent it with respect to point A, so that moment of this resultant about point A must be anti-clockwise. That means can you represent it like this resultants here, I will try. Below point A or above point A, but direction same means what I represented here, in which quadrant? Fourth quadrant. So if I'll represent this resultant, right, below this point A, so this movement of this resultant, what is possible here is in which direction? Anti-clockwise direction. Say this is the position. What I represented here is nothing but what? This one is R. This is what? R, right? This moment of resultant about this point is in which direction? Anti-clockwise. Now distance is important. If distance if we try, so which one is the distance? From point A, perpendicular distance means from A, if I draw a line perpendicular to this line of action, means this is our distance. Where you have to find out point of application with respect to this point A, means say distance A, and this is perpendicular. That means moment of resultant becomes what? R into D. Directly perpendicular distance is possible. Therefore, if we apply Varignon's theorem, our equation is what? Sum of moment of all forces about this point A, taking anti-clockwise moment positive, equal to moment of resultant about point A, taking anti-clockwise moment positive. This one is the 76, and this one I'll write R into D. That means here D comes out to be what? 76 upon R. That is 76 upon R value, you know, R is 305.28. That means what D will get here is what? 0.248 meter. So in this problem, you have calculated perpendicular distance. Previous problem, first problem from general force system, X and Y was asked. So you can find out X, Y. That means in general, I'll write here. In general, moment of resultant, if you'll find out, moment of resultant you can write by three ways. Moment of resultant. The simplest way of writing moment of resultant is what? Magnitude and perpendicular distance. One possibility. Or if moment of Ry, if we take the Ry vertical means distance from that point becomes horizontal, Ry into x. Or if we take moment of horizontal component, horizontal, that means what distance here will get? Y distance. So if perpendicular distance is asked, we'll write R into D. If horizontal distance you have to find out, we'll write Ry into x. Means we'll resolve that resultant and then that distance x will find out. And if vertical distance, if you want to find out, we'll resolve, we'll take moment of horizontal component. That means in problem, what are the possibility? Find horizontal x distance means x intercept, vertical y distance means y intercept, or perpendicular distance, depending on what is asked in problem, we'll write R into D or Ry into x or Rx into y. In case in problem which distance you have to find out is not asked, maybe horizontal or vertical or perpendicular is not mentioned, which is the easiest way to find out distance? R into D. If nothing is mentioned, then we'll apply directly R into D, and in one step we'll get what? Perpendicular distance. Okay, thank you.